spent a lot of time in this unit working with lines, linear equations, tables, and graphs. And the goal here is to start using them in more real-world contexts, which begs us the question of what happens in real-world problems? A lot of our equations and answers have had nice, clean numbers. What happens when we don't? So for example, let's say we were opening up an ice cream shop. And we wanted to know how much ice cream do we need if it's 85 degrees outside, because ice cream, like other foods, is very perishable. So if you order too much ice cream, you're actually going to be wasting money. But if you don't order enough ice cream, you might push away your customers. So what we did from this problem is we made a series of data basically detailing the temperature outside and then how much ice cream we sold that day. And what happens is through this, in general, when the temperature increased, the number of sales of our ice cream increased. But it wasn't directly linear. So what we would have to do in this example is what we call creating a line of best fit. So a line of best fit is a line that goes through our data that gets as close to every data point as humanly possible. Now, when you're creating a line of best fit, you have to be really careful, because if I drew a line like this, that hits quite a few points, but it definitely doesn't hit all of them. If I drew a line closer, to the bottom from here, then it hits a few more points. But I would say the most accurate and realistic line of best fit would be right about here. Now, if you notice with each of these lines of best fit, they look a little bit different. And if we're looking for an answer of 85 degrees, which would be somewhere over here, depending on the line that you're working with, your answer could be drastically different. And when you're comparing real-world problems with equations, different lines of best fit can give you drastically different answers. So let's go, how do we pick a line of best fit? What I like to do is I like to think of each of these individual points as trying to touch the line. The perfect line of best fit is as close as possible to each of these points. Now, if I hit this point on the nose and this point on the nose and this point on the nose here, then I'm going to miss all of these points at the top. So I say this is not the best possible line of best fit. So what I frequently do is I look through my points and I try to find a place that seems like it can cut through as many points as evenly as possible. And I would say that the red is our best possible line of best fit. But everyone's lines are going to be a little bit different. Unless you're using a computer or a very powerful calculator, your line of best fit will not be exact, and it's not expected to be exact. But you do need to defend your answer. So if you gave me the green line versus the red line, I would expect you to be able to explain why your line was better than the other. If I was arguing for the red line, I would say that the farthest away points appear to be these two. These are our outliers. Maybe this one's an outlier as well. But those are not that far away. If I was arguing for the green line, I would say that I hit a bunch of points on the nose as close as possible. So I do have a few extra outliers right up here. But maybe you're arguing that those aren't as valuable. And as you can see, there can be some different answers. So let's actually answer a question using line of best fit. It says if you have a grip, this should say grip, strength of 140, what would you expect your arm strength to be? And if you see on this graph, grip strength is measured in PSI down here on the bottom. And as your grip strength is increased, it says that your arm strength should increase as well. And if you think about in general, if you have a stronger arm, you should have a stronger hand. But it is not always the case in every situation. So we have to find a line of best fit to balance. Now, our grip strength down here is 140. So we're saying, what would you expect your arm strength to be if that was your grip strength? So if I was drawing a line, I would say, okay, so I see a bunch of points here. I'm actually going to try to draw through. Oop, that is not a line there. Let's try this one more time. I think the best line would be somewhere right about there. It seems like that's cutting through as many points as possible. But you could tilt it up a little bit and still make a good argument. It just kind of depends on what your point is. But if I picked this as my line, I would look up at my grip strength of 140, and I would say that my arm strength is right around here, which would be about 110. Once again, because it's estimating, we've talked about this a lot this year, your arm strength would be about 110. We don't know what the label is here, so we're going to just put units. If I needed to make an equation from a scatter plot, you will frequently see these types of problems on IXL, where it'll give you the scatter plot, but it's asking you to find the equation. Now, we know that our equation from the last section that's easiest to work with is slope-intercept form. Y equals mx plus b, so we need the slope and the y-intercept. Now, the y-intercept is down here at the point b equals 1 or 0, 1. Our slope is a little bit trickier, but they gave us 2 points that hit on corners so we can count. 1, 2, 3, 4, 5. And we go over 1, 2, 3, 4, 5, 6. So our slope is 5/6, which means our equation would be 5/6 x plus 1. So, which brings us to the last slide, which is we're going to put it all together. If we're given a story that we need to solve and we need to make an equation from that, how can we do it? So, the scatter plot to the right shows the number of CDs in millions that were sold from 1999 to 2005. If the trend continued, about how many CDs were sold in 2006? And we'll make an equation from this. Now, I see a possible line of best fit going through our points right about there. So if this is 2006, I would say our answer is going to be right here, which is going to be about 650 million. Now from here we want to make an equation, once again in y equals mx plus b form. And we're going to say that x equals 0 at the year 1998, which would be right here. So at that year, it looks like our b value is 1,000. So b equals 1,000. And now we need to guess our slope between one year to the next. And this is where it gets a little tricky. So I would say that if at 1998 there was 1,000 million CDs sold, it sounds really odd, and then in 1999, it looks like there's about 960 million sold. That means our slope would be about -40 million per year. When you're dealing with line of best fit, you're going to have to estimate somewhere, and on this problem, we estimated with our slope. So that means our equation would be y is equal to -40x plus 1,000. And I like to put the word about because we do not know if that would be exact or not. Line of best fit is definitely tricky, but the nice thing is that we are going to work with a lot of real-world problems. So make sure you ask questions if you need it. Otherwise, the video retake is up and available if you didn't score 3 out of 4 or better.